Welcome to the AWS for AI podcast.
Welcome to AWS for AI, the podcast where we explore cutting-edge AI solutions and the innovators behind them. I'm your host, Hamza Mimi, AWS Solution Architect. And today, I'm thrilled to welcome a very special guest, Julien Simon, VP and Chief Evangelist at Arcee.ai. I actually knew Julien from a past life back in Paris when he was working for Hugging Face, and I was personally impressed with his depth of knowledge, helping hundreds of customers solve their AI challenges, always sharing his unique perspective. Julien is a strong advocate for open source AI, small language models, and is dedicated to helping enterprise clients develop top-notch and cost-efficient AI solutions. With over 30 years of tech experience, including more than a decade in cloud computing and machine learning, Julien is committed to daily learning and is passionate about sharing his expertise through code demos, blogs, YouTube videos, and more. At Arcee.ai, he's working on things like the Arcee Mirage model, an Arabic language model which consistently outperforms the state-of-the-art models across most Open Arabic large language benchmarks, showcasing remarkable improvements and securing top spot on Hugging Face leaderboard. Before joining Arcee.ai, Julien was Chief Evangelist at Hugging Face and Global AI Evangelist at Amazon Web Services. He also serves as a CDO at prominent startups. In 2021, Julien was ranked number 1 in the list of top 10 AI evangelists worldwide by AI Magazine, with the likes of Flex Friedman, Ilya Sutskever, and others shaping the industry. Julien, it's a pleasure to have you today with us.
It's a
Welcome
pleasure
to the
be
show.
here. Very happy to be in Dubai and very happy to be your guest today.
Thank you. So before going into the technical discussions, and I'm sure you have a lot of things to say, I want to go back to your personal story getting into AI. And now, well, AWS, Hugging Face, Arcee.ai. What brought you to first to AI in general, and then what's your story getting into Arcee.ai?
It's a long story. I'll keep it short and hopefully not boring. It all started with MySQL. Back in the early 2000s, I was working on web platforms, e-commerce websites, that kind of thing. And, data was everywhere, product catalogs. We had to manage that. So, MySQL, Postgres, Oracle, you name it, right? And then I joined another company working in ad tech, where data was structured, so still databases, but mostly unstructured, web logs with ad displays and clicks, that kind of thing. And we were starting to use machine learning to predict clicks, click-through rate prediction. And we actually built a very large Hadoop cluster, multi-petabyte cluster, which was insanely large at the time. And I started looking into machine learning. And I have no formal training in machine learning, but I thought, okay, that's cool stuff, trying to predict behavior just from web logs, that's interesting. So I started learning about it, and the ball, has kept rolling since then. And at some point I decided, around when I joined AWS, actually around late 2015, 2016, AWS started launching their first machine learning services and AI services. And I thought, okay, so deep learning, what is this? I'm curious.
Interesting.
And then kept on learning and decided I wanted to focus on this and convince my boss to, let me focus exclusively on AI ML, which, very few folks properly understood 10 years ago. And they said, yeah, okay, go do your thing, leave us alone. And yeah, that's how it went. Learning every day, and starting from scratch and trying to figure out the use cases, what's in it for customers. Not the algos, not the theory. That's useful, but first, what can I do with this as an enterprise customer or startup customer? What can I build? What can I solve? How can I improve the user experience? How can I improve the agility of my company? The business challenges, the real life problems, and then figuring out, okay, what technology is the best fit, what model is the best for this, and it changes every day. So you have to keep learning and keep experimenting, and that's how I describe my job. I waste a lot of hours, a lot of evenings learning or unlearning sometimes, and trying to figure out things so that you don't have to, right? Because if I spend 20 hours banging my head on a problem, and I can do maybe a YouTube video to explain it properly, hopefully, and this gets thousands or tens of thousands of views, then I did save hopefully a lot of time globally for the user community, and that's what I like.
Thousands and thousands.
That's
of
my leverage.
Absolutely. So now Arcee.ai.
Yes.
Can you talk a little bit about what's Arcee.ai mission? What are some of the things that you're working on, and how are you trying to achieve that mission?
So I describe Arcee.ai as the SLM champions and small language model champions. And I mean that in two ways. So first of all, we are championing SLMs. We are convinced that customers will get more value out of their services and products if they use small language models versus large language models. And I'm sure we'll double click on that. Yes. So we're convinced this is the best way forward, and it looks like an increasing number of people agree with that. And we're also SLM champions because we are pretty good at building models. So you mentioned Mirage, which is our Arabic language model. We build models. We start from the best open source models available today. So which could be, llamas or Mistrals or Qwens. Qwen 3 just came out. So pretty sure we'll have something to say about that in a few weeks. And we run them through our post-training stack, which again is our own IP. It's a list of open source libraries we've built and invented to not only build outperforming models, but also build them in a very cost-efficient way. So we're model builders. We share some of the models back on Hugging Face. We keep some of them for commercial customers, and we're also a platform builder. So we take our models and we deploy them on SaaS platforms for inference with cool things like model routing. Maybe we'll talk about that, and agentic workflows. So trying to advance AI to the next level. Because we realize, and our customers realize, that no single model can do the job, right? There is no Swiss Army knife model, just like there is no Swiss Army knife database or Swiss Army knife programming language. You need to use the right tool for the job, and we're trying to help customers do that. So
what are some of your customers, industries, geographies? Where are you focusing right now?
So Arcee is an American company. Most of the team is still based in the US. There's a few of us in Europe. I'm based in France. I think I'm the only one still. So we have a US focus because that's the natural territory, I would say, for Arcee. Having said that, we have international conversations. One of the reasons I'm here this week is because I'm meeting with some customers, potential customers, and partners, and by the time you watch this, I'm sure you will have heard of our announcements with the GCC region. So we're pretty serious about about the region. We see a lot of AI activity here, a lot of interesting customers and partners, and we're hoping to help customers here as well.
I can only say I'm also seeing the same.
Yeah.
And it's really huge here, but it's huge everywhere.
Yeah.
But here, in
things are
particular,
moving very fast.
Yes. I want to talk a little bit about some of the use cases. Or obviously, you work with some customers on building
Sure.
small language models, but you also have some products.
Yes.
Maybe talk a little bit about some of the use cases you're working with some of your customers.
So if, long story short, first we had LLMs, and the initial vision was, one LLM to rule them all, and you could do anything and everything with a single LLM. That didn't work out well, especially for customers who have, very strong privacy or very domain-specific questions. And then, of course, the open source community started building great models, and before we knew it, we had 1 million models on Hugging Face, and probably 1.7 million by now.
Oh.
Which is amazing, but creates complexity because which one do you use, right? And it can be a little bit paralyzing. So and everybody started fine-tuning models, trying to get their own domain knowledge embedded into the models, and getting some success, but probably not as much as they wanted. And I think at the end of the day, the world is a little more complicated than that, building automated workflows or smart workflows is more than one model. So yes, you need a collection of models, and the smaller the better, because small means fast and less expensive, etc., more scalable. But you need also IT tools, right? You have interesting data in Salesforce. You have interesting data in GitHub. You have interesting data, in all your apps, in your email server, etc. So trying to build a single model that replicates all that knowledge is very hard. Absolutely. And it fails most of the time. So the right approach, which the one we advocate now, is use models for what they're really great at. Data analysis, data conversion, story writing, obviously, and use them with the data coming from your existing IT systems, where you have your customer knowledge or you have your documents, etc. And use each bit for what it's great at. And once you do that, then the use cases become, I would say, infinite, because you're able to combine models and external tools into an infinite number of combinations, right? Instead of trying to teach a single model to do, customer support and fraud prevention and all the usual document analysis, right? All the usual suspects. And I think that's at least that's what we mean by agents. I'm not quite sure what some people mean by agents. What we mean is combining external tools, SaaS or APIs or ISVs, etc., combining them with models in smart and simple ways to deliver automation and augment the productivity of your workers. And yes, we work with companies across the board, from financial services to insurance to retail. If you had asked me that question 10 years ago, I would have told you financial services and everybody else behind, maybe retail. Now we see customers in literally all verticals, ed tech and even companies that are not that sophisticated, definitely not just tech companies, folks who just have data and who need to automate and scale. And so pretty much everybody.
Oh yeah, AI across the board, everywhere.
Be more cost effective, be faster. Who doesn't want that?
Absolutely. You also have some products beyond the ones that you're working with your customers directly. Things like Conductor, like Orchestra, like Merge Kit. What kind of problems are you solving with these?
So initially, Arcee started as, like I said, as a model building company, and specifically as a custom model building. So we work with companies coming to us saying, "Hey, we need a model for this particular use case in this particular industry. We think we have good data. Can you help us?" And of course, we did. So we did quite a few of those. And again, as I mentioned earlier, I think we were successful because we didn't just grab the fine-tuning notebook from Hugging Face and run it, right? And that's a good notebook. No worries there. Hugging Face is doing a lot of amazing work, but things are more complicated than that. And we realized there's a different way to build models. So yes, you mentioned MergeKit, which is the model merging library we invented. And model merging is a crazy technique where instead of training models, you literally merge them. And it's exactly what the name says. You take model A, model B, and model C, and you run a math operation, literally. And it's almost model A plus model B plus model C divided by 3. That's a gross simplification, but that's what it is. So there's no training involved. I can run it on my laptop in a few minutes, and you can take single task models and merge them into multitask models. That's one use case. And if you look at the Hugging Face leaderboard, which you mentioned, most, if not all, of the top performing models involve merging. And companies like Google mentioned that they use model merging for the Gemma models, etc., etc. So it's a popular technique. Model distillation is another great technique. Thanks to DeepSeek, I guess now people have heard of distillation. But we've been doing that for a while as well. So we have this stack, which is, I would say, sophisticated. Definitely not just vanilla techniques that you can run in a simple notebook. And that's how we build great models. And then, so we call that post-training, okay? Yeah. So that's the post-training element. Then once we have those great models, of course, because I said earlier, no single model, even ours, will solve everything. We built an inference platform, and you mentioned it's called Conductor. And so Conductor involves model routing, where every prompt you send is analyzed by a tiny router model. So we look at complexity, we look at domain and a few more things. And based on that, we make a really quick decision and send it to the most appropriate model. And hopefully, we send that to the smallest model possible, because it's going to be faster, it's going to be more scalable, and it's going to be more cost efficient. If you need to write a meeting invite, or if you need to summarize a document, or if you need to translate a document, small models can do that extremely well. So if you send that to an LLM, of course they will do a good job, but they will do it 100 or 200 times more expensive, right? You'll pay tens of dollars per million tokens instead of paying, fractions of a cent. So at scale, it adds up very quickly. So that's the whole idea behind Conductor. Find in real time the best model for each prompt, and optimize for cost efficiency. And I could show you some examples where small models do as good a job as the top models from OpenAI or Anthropic, that at a fraction of a cost. So that's Conductor, and it's a really, really cool way to spend your money wisely, right? Get more bang for your dirham, or dollars or euros. And then we have we have Orchestra, which is our agentic workflow platform, which is has a very simple UI where you drag and drop boxes. So you want to connect Salesforce as an input to an SLM, and then you want to have maybe a bit of custom code to do something else on top. Drag and drop, connect, use the models, run the workflows, deploy them as APIs, which your apps can invoke, or trigger them through a chat interface if you want to expose that to your users. So it's always the same philosophy. It's like no single model, even the best open source model, even the best RC model is not enough. So you need a collection of models that you can use for the right, at the right time for the right thing. And in some cases, with Conductor, you let the platform itself decide when to use which is great because models change all the time and nobody has enough time in their day, even if you have a large team, to evaluate everything constantly. Yeah. It changes overnight. So we do that work and we let customers focus on what's important, which is, take care of business, take care of their daily business and their operations, and not run evaluation tests on models constantly, which is, painful and time consuming.
Too many stuff to unpack. And,
we do a lot.
Let me double click on the model merging technique and
yes,
and generally how you actually build small language models.
Yes.
So you talked about distillation, there's quantization,
yes,
merging, and training from scratch. How do you get the best small language model?
So first, I would say, we're really pragmatic. We're a fun way and a slightly cheeky way to say it would be, some people have spent billions of dollars building, the Mistrals and the Llamas and the Quens and the Phi models and the Gemma models, and they're all great, So let's start from there. Okay, let's start from those models, and our research team, spends a lot of time again evaluating those models. They're connected with a lot of those teams, and so they see that, hey, this new model comes up and it's better at this particular set of tasks, or maybe it's better on that language, or maybe it's better at Python, or or it's better on finance. Who knows? And that's useful information. So then, depending on what we're trying to build, are we trying to build a customer model, or are we trying to build a general purpose model that we want to add to our platforms? They can go and select the right model, and then they run the post-training process, which I mentioned. And we're able to do that repeatedly because, again, we do it in a very cost-efficient way. So we don't spend $100 million, post-training, Quen, whatever. We don't have that money, and if we had that money, we'd use it for something else. So that's the value of the again, model merging and model distillation and other techniques that we've implemented, and they're super cost efficient, and they've repeatedly demonstrated that they were able to deliver outperforming models. And in fact, every time we published a model on Hugging Face, it was number one in its size category. And then over time, it changes. So if you're looking at Hugging Face today, it's probably not number one anymore, But every time that model was the best. And I suspect, the team wouldn't release it if it wasn't anyway. They worked very, very hard to make sure it was the best and customers would get a lot out of it. And there are so many ways you can improve those models. So post training, synthetic data. It's the topic no one ever discusses. People are obsessed about transformer architectures and this new attention layer or this new tweak on the attention layer. And don't get me wrong, I'm an engineer. I love that stuff. I spend hours reading it, trying to figure out the math again, and hopefully doing those YouTube videos that you like. but it's not, like the data matters. And I remember very well, when Falcon from TII came out, that's a while ago. Yes, they had tweaks on the model architecture, but it was specifically a better model because they had spent a ton of time on the data, cleaning and curating the data, the so-called refined web data set, removing all the bad stuff that lives in public internet data sets, and doing that is critical. And I can never say enough that if you are fine-tuning models, if you are building your question and answer data sets, the quality, the diversity, the complexity of your questions is critical. Don't think you can just take 100 Q&A pairs and fine-tune and get good results. You will have good results on those specific QA pairs. But, you and I, we wouldn't ask our customer support banking app the same question the same way, right? So diversity is important, complexity is important, and we spend a lot of time working on that. And that's, if there is a secret sauce, that's it,
So most of these techniques will require the models to be open source.
Yeah.
And I know you are very passionate about this.
Yes.
But I feel open source is not yet well defined in AI and in generative AI in general.
It's the term is wrongly used. I think
it's still early age.
Yeah.
We're starting to see obviously the open weights.
Yeah, open weights.
And there are some other initiatives. Just want to maybe touch on what do you see from your perspective, and obviously you also have open source and commercial models.
Sure.
And what's your perspective on open source on AI, and where do you see this going forward?
So you're right. I think we should really say open weights, because that's what the Hugging Face models are. You have the model architecture, you have the weights, you can load them with the Hugging Face libraries. Very, very few models are actually open source. If you want to say a model is open source, then everything needs to be open. So you need to have the training data set. You need to have the training code. You need to have maybe the post-training code, the full recipe, right? If I bake a cake and I tell you, it's an apple pie. Okay, it's got an apple pie architecture, and it's got sugar and apples and flour. You know what I mean. It's like it's not enough to actually bake yours. You need the full recipe and all the tricks. Even the recipe doesn't have the tricks that and the know-how that a great cook has. So I think we should really say open weights. There are very few models that qualify as open source. To their credit, Hugging Face has built a few where they did share absolutely everything, and I think that's interesting, just to contrast with what you usually get. I think the contribution of the community is absolutely critical, and I think it's stronger than ever, because it used to be the first few meaningful open source or open weights model came from Stanford and Vicuna and Alpaca, and then Meta joined the fund with the Llama models, and then a lot of people started joining the fund. So again, and we see actors that are not just US actors. TII joined, and Alibaba and the Quen models are very significant right now. And I'm pretty sure before we know it, we'll see great models from India, and there are some models coming out of Asian countries, and we'll see models coming out of Africa, etc. And that's great, because I keep telling everybody, and I mean no disrespect to anyone, but why would a US West Coast team of engineers be the best people to build a Swahili model or a Tagalog model? Not to mention, Indonesia. When I was in Singapore a while ago, I say, how's the support for Indonesian? And people were laughing politely and saying, did I say something stupid? And I said, no, but we have 100 dialects in Indonesia alone, and India is pretty complex, and Africa is pretty complex, and so those. Not to mention the cultural differences, which you have to account for. I live in Europe, so I'm kind of in the middle. If you look at the map, so I look east and I look west and I look south, and I see different folks with different languages and different cultures and different religions, different everything, and that's perfect. That's the way it should be. But those differences should also be reflected in the models that you use. And no one needs to judge that. If you're in Dubai, in Rome, do as the Romans do, right? Well, in Dubai, do as they do in Dubai, and in Singapore, it's the same. And a single company or a very small set of companies, all of them in the US, cannot be in charge of that. So I'm all for local initiatives, local languages, local cultures, local trainings. So UAE is doing pretty well, is very actively involved in that. In some other parts of the world, it's more complicated. They don't have the same resources. But we need to encourage that kind of work. And I think this is more interesting to me, that discussions on sovereignty. Sovereignty is a bit of an abstract word. So if you tell me, oh, we need sovereign models, I'm not quite sure what that means. If you tell me we need a model that we're comfortable deploying in schools from a language, a safety, a cultural, and even a religious perspective, okay, now I'm with you.
Yeah.
Okay, and it doesn't matter what I think, because if I want to build a French model with the French way of life, let's go do that. But if I'm going to build a model or help people in Singapore build a model for them, their rules.
Exactly.
That's the way I look at it.
You touched on synthetic data, and this also contrasts with if you're using a large language model to generate that synthetic data that didn't have those nuances.
Yes.
How is synthetic data useful in that scenario?
Yeah, it can be a vicious circle. It's like mad cow disease, There's a risk. Feeding AI models too much AI generated data, when does that go wrong? So I think I think synthetic data is a good way to multiply and diversify your data. So you can ask your domain experts. Let's say you work at a telco or a bank. You can ask them, okay, what are the top 100 questions that our customers are asking? That our chatbot should be, perfect at. They'll come up with that. Everybody knows that, and you can write those. Now, it's probably the 100 topics, right? But again, take 10 people in the street and tell them, okay, you lost your credit card. How would you ask? What would you ask your support app? Or you're moving and you want to change the address on your phone bill, or that kind of stuff. Even simple questions, people will have a very different way of asking them. And not everyone is a native speaker as well, right? Even with text, I'm not even discussing voice and accents, but I don't speak Arabic, but let's say if I was a basic Arabic speaker, I would probably ask the question in a very
different way,
childish way. You would ask it in a more elaborate way, obviously, but I'm still looking for the same answer. So models are great at doing that. You can tell them, okay, this question, write 50 versions of it, accounting for, I don't know, anything you're interested in, cultural level or age. How does the teenager ask that question? How does a senior person ask that question, et cetera, et cetera. So if you do it like that, I think it's actually very useful, and it helps you enrich and complete your data sets in shorter time. Generating net new data from scratch and relying too heavily on it makes me nervous. Because if that large model you're using to do the enrichment and the generation, if that model has a bias, then you're just it's in there, right? It's in there. It's very hard to detect, and it's like bad code. It's difficult to fix. It's technical debt, and I don't think you want technical debt in your data sets.
So I want again to tackle on different topics. So for the synthetic data, the point here is to use the large language model, and this is the same also for small language models, basically using that knowledge that's already available and get the human in the loop.
Yes. Oh, of course, always.
The yeah, and the
And probably
technical-
use several models. Like if
Yeah.
you don't rely on the same one all the time. Use different ones so that even if one of them has a slightly weird
you
take
always-
on whatever topic, it averages out. And be very critical and review them and be super critical on what the model is doing.
Okay. So let me double click on small language models now. This is an undefined topic. So
Yes, I can give you my definition.
Each person have their own definition.
Yes.
I've heard thresholds about the parameters, about the compute capacity, about all sorts of things. What to you is a small language model?
So my definition, and it's not academic, and even internally at RC, I think people would disagree with me, and that's okay. I love disagreeing and debating. My definition is anything you can run on a single accelerator without having to split it and shard it and do complex ML engineering. What you can load on a single accelerator, to me, is a small language model. Okay. So you could counter that. Well, accelerators get bigger. So if I have an accelerator with 500 gigs of RAM, is that a small model? So no. I think realistically, anything larger than 70 billions cannot be called a small language model.
70. I've heard 7.
It depends. I mean, if you're looking at, what's the target deployment for that? If you're looking at devices, if you say, I need something to run on phones, of course, you're looking at single-digit billion models. But you can very nicely run, AWS has a wide, putting my AWS cap on for a second, sorry, folks. But AWS has a wide range of accelerated instances. Okay, so you have lots of different GPUs, and then you have, the AWS chips, Trainium and Inference. So there's a lot of choice. And I'm always coming back to cost efficiency. And when I was at AWS, I was telling customers, please use the smallest EC2 instance you can find, right? Yeah. If have you used T2 Micro was my catchphrase, and they were looking at me like I was an idiot. And it's like, well, have you tried it? Look at me.
Start small.
And it's like, no, I haven't tried it. And I say, okay, try it. It's not going to take long, and maybe it just works. And it's going to cost you a few cents per hour instead of maybe a few dollars per hour. And sometimes he would come back to me and say, oh, yeah, well, it's actually not bad. And it's like, okay, good. You can buy me a coffee now. I saved you thousands a month. But seriously, I think it's the same for AI. I think obsessing over cost efficiency is critical. And because AI is all about scale. AI is all about automating things and accelerating. So maybe completely automating them end to end, document processing, or it's about augmenting, the business users or developers, right? Code generation, is very, very, a very cool technique. I use it every day. But helping people just be more productive and spend more time on what matters and help them get rid of those silly, low value tasks and free time to focus on what matters, right? So if doctors can spend less time typing, reports or reading reports, and if they can spend more time with the patient, great. Same for teachers, same for a lot of jobs, actually. Yeah. More face time with humans and less time on paperwork, okay? So if AI can do that, that's good. But that means if it works, it needs to scale, and you need to free as much time as possible for humans to do their thing. So cost is scale equal costs and cost equal scale. If you build AI that's used twice a day in your organization, what's the point? So you really need to deploy this to every possible location. And so the cost needs to be minimal, and for the cost to be minimal, you need the least amount of infrastructure, which for AI means the smallest compute you can find that gets the job done for inference. So either the smallest GPU or even CPU. I mean, I'm a fan of CPU inference, and yes, you heard that right, CPU with a C. I do a lot of stuff, a lot of work on that, and you get fascinating results because the models get so small that it's a positive flywheel again. Amazon loves flywheel, so they get small. You can run them on smaller hardware. Because you can run them on smaller hardware, you can run more of them for the same budget, and so you just amplify your AI efforts. So, yeah, small to me, I think the sweet spot right now is around, I would say, 10 billion, 8 to 10, but it's dropping. Yeah. And I can give you an example. I mean, we released in February, I think, a 10 billion parameter model, which is called Virtuoso Lite. Virtuosos are the name of our general purpose models. And this model, so 10 billion parameters, is better than the 72 billion parameter models we released last July. And this one was, when it was released in July 24, was the best 72B model available on Hugging Face. Okay, so can I look at you in the eye and say 10B is the new 72B? Not really, because 72B models today are obviously better. Okay, but it means for a lot of business use cases where you would have needed a 72 or maybe a 34 billion parameter model 6 or 9 months ago, you can get the same performance today, the same business quality from maybe a 10 or maybe an 8 billion parameter now. And it makes a world of difference in terms of deployment. Absolutely. Because a 10 billion parameter model can run on the smallest GPU instance available on AWS.
I've seen your demos on Graviton.
Yes, and you can run them on Graviton if you have small scale use cases. So that's where we are. Yeah. That's where we are, and that's my prediction.
So what's your advice then for people starting to run their models? How to evaluate the right size, the right model, and the right infrastructure?
Yeah. So I'm not gonna say have you tried T2 Micro, but I'm gonna say have you tried the best 7 or 8B model available today? Start there. I mean, you have smaller models, like you have Google Gemma models that are very good, or Phi models from Microsoft that are very good and a bit smaller. But I would say, okay, let's not be extreme. Let's be reasonable. Let's start at 7, 8. Run them on the smallest GPU instance on AWS, which is going to cost you something like $1 an hour. Maybe $1.10, or that's the price range. So the cost of experimentation is very low, and build, if you have evaluation data sets, if you already have Q&A data sets that reflect what your users would be doing, okay, go and run that. Score with your internal metrics, and of course do human review, as you said, human in the loop. Ask your domain experts to look at the answers and tell you what they think. And if it's good, I mean, try shrinking. If it works with the 7B or an 8B model, try 5. Try 3. Take the best ones available today. 3B today goes a long way. Right? So
when should you try Graviton in production?
I think you should try. So first of all, there are some scenarios where you have no GPUs. Okay, so some regions, some AWS regions, and this is constantly in flux. Okay, but some AWS regions are not GPU rich. Okay, let's put it this way. So maybe you don't have the latest generation of GPU instances. Maybe you have very few, and as a smaller customer, it's very difficult to get quota. Everybody's trying their best, I know, and I know capacity planning is very hard. So it's not a cheap shot at anyone. It's just the reality. It's difficult to have the right amount available everywhere all the time for everyone. Okay, it's a limited universe. So there are some regions where you cannot do that. There are some scenarios, and I know they're not for AWS, but there are scenarios where you're not in the cloud. Yeah? Maybe maybe you have a chain of restaurants or supermarkets, and you have a server or you have a telco rack somewhere in there, and there's a server, and you wondering whether you could run something locally. Okay, so the edge, and of course you have devices. Okay, so there's a whole universe that doesn't really have GPUs, and in that case, if you have the right type of CPU and if you know how to optimize models, you can get really good results. Graviton are based on ARM technology, so generally ARM CPUs are well supported by open source tool to optimize models. You mentioned quantization, shrinking models. So there's a whole bunch of techniques that apply. But even coming back to my beloved cloud, I think there are scenarios where it makes sense not to use GPUs. Everybody loves microservices and everybody loves, scale out, etc. And fine. So, and I see customers who are building those Kubernetes clusters with microservices, and it's very nice and neat and, looks great. Hopefully it runs great too, but it looks great. And then they send all the AI inference traffic to this huge single point of failure into a single GPU instance or a couple, and they only have a couple because they are expensive and they're difficult to procure, etc. So I'm like, oh no, everything was well architected, and then bam, you have this huge single point of failure. So is that really necessary? Can we not scale out inference in the same way? Can we not, for small scale workloads, can we not embed maybe the models, the optimized SLMs on the same instances that run the application code? It's of course, if you need 10,000 hits, 10,000 inferences per second, of course this won't work. But not everyone needs that, and maybe sometimes you just need that local friendly model to do something for you, small scale, and you can run this in place instead of having that GPU instance, even a small one, that sits idle 99% of the time, waiting for you to need it, but costing you money all the time. So there are lots of, I keep saying there's a GPU-less architecture to be invented. So, I'm putting the word out. If folks are interested, they know where to find me. And yes, we'll still need GPUs, and we'll need them from different providers, hopefully. And we'll need the accelerators like Trainium and Inference. We need all the options we can get. And because, again, we need the right tool for the job. Right? There is no single technical solution to anything. Sorry. There's this famous paper, There is no silver bullet, 1986. I encourage you to read it. It was true in the 70s. It was true in the 80s. It was true in the 90s. It'll be true when I'm long gone. Okay. There is no single tech solution to everything.
You mentioned, you touched on the hardware parts. And obviously for small language models, edge scenarios are a must.
Sure.
But even when training models in the cloud, at Arcee.ai, you used Trainium, you reduced your cost by something like 98%?
Yeah, we did use Trainium for one of our customer projects. Generally we've used, and we're still using SageMaker Hyperpod too.
What kind of, so there is the change from, if you've been using CUDA in the past and need to change that, there is also a learning curve. How did you do that? What do you advise people moving to?
So Trainium? I think it's I think there are two questions here. The first one is, how difficult is it to run large training at scale? And the answer is more than you think. And even on AWS, which is rock solid, as we know, and I've experienced it, stuff breaks. And when you run hundreds or possibly thousands of GPUs over extended period of times, they die. GPUs die, instances go, crazy and become unreachable, And the problem is that, the distributed nature of those training jobs makes them very fragile to any kind of disruption. So yes, you can use checkpointing, and yes, you can restart the job from the last checkpoint, which could be hours ago or days ago.
Depends.
So, but it's just extra overhead. It's difficult. So I think Hyperpod is interesting in that sense. And we were using it at a Hugging Face as well, because it takes, for the long running, sizable training jobs, which not everybody runs, but the cluster management infrastructure is valuable. Just like, when you use ECS or EKS, lots of things happen under the hood. And yes, you could run your Docker cluster on EC2 and manage every tiny thing yourself. But hey, service teams have done it, okay?
Yeah.
And I think they know what they're doing.
So
the managed service story still works for training.
So Hyperpod, what problem does that solve for you? Obviously, hardware fails. And especially in training, you have high energy coming in, high training jobs, high GPU usage.
Yeah, sure.
So
sure.
What does Hyperpod, for people that does not know about Hyperpod, SageMaker Hyperpod?
So I would say it's really it's managing, it's managing failures and restarts, and it gives you, monitoring and observability into large training jobs, which yes, you could build yourself, but again, is that where the value lies? I mean, do you want to spend more time, curating your data and improving the model, or do you want to reinvent the wheel? I know what my answer is, and again, I'm an engineer. I love to build stuff, but your primary mission is deliver a great model, and the elasticity and the resilience of Hyperpod is valuable. And when it comes to Trainium, I think Trainium is an interesting option. There is a learning curve. I'm known for being brutally honest. So there is a learning curve, and I'm brutally honest with the Trainium team, and they're patient and they're listening. But there is a learning curve. So I would say, generally, if you work with well-known architectures, okay, so you have a Llama model, or you have a Mistral model, whatever, something that has been out for a while and that is well supported, well understood. The learning curve is not that bad. Okay, the learning curve is not that bad. You'll find some notebooks, you'll find some examples, and you can train, and of course you will get support from your account team, etc. So we've had some successes, we've had some failures, and I've been long time supporter of Trainium and Inference. I think no one has more content out there than I have. But I think that gives me the right to complain from time to time.
But why should new startups do that learning curve? What's the
I think if you're
outcome there?
if you're looking for cost efficiency and scaling, you'll get it. It's fair to say it's easier for AWS to give you access to a good number of Trainium or Inferentia chips than it is for them to give you access to the latest P5 instances, right? Because on the former, they have full control. They build the chips, they deploy them, they optimize them. So the value chain is shorter. They have a strong incentive to be successful there. And the latter, well, all depends on the NVIDIA supply chain, which can be complicated at times. And obviously Amazon is training a lot of models themselves. So they have experience doing that, and that was factored in, Trainium as well. So the cost benefits are real. I saw them personally. I mean, I saw them in organizations that I worked at. I heard it from customers. So if you're looking to cost optimize from day one, I think it's an interesting option. If you really struggle with getting access to the latest and greatest GPUs, well, know that there are plenty of Trainium chips depending on your region. Again, I'm not up to speed on the Dubai region. So I wouldn't comment on that. Trainium 2 came out at re:Invent, so that's the next level up in terms of performance. So yeah, it's worth a shot. It's worth a shot if you want to try something a little bit different, and if you know you will have to scale and you want to be independent of whatever NVIDIA decides to do or not to do next week. The world is getting complicated.
Yeah.
There were some announcements today on GPU exports that are a little bit worrying. So you never know.
So before we end, I want to get some of your long experience working on AWS. And if you talk today to a new startup, a public sector organization, an enterprise, starting from scratch,
yes,
I want to hear from you the good, the bad, and the ugly. What things should they be looking at when building on AWS AI workloads?
So I would say, number one, I don't know if it's good, bad, or ugly, but don't treat AI differently from your typical software engineering efforts. A model endpoint is an API. For all I know, it's just another microservice. Okay, so it's not different this time. It's never different this time. So again, cost, scaling, monitoring, observability, security, compliance, all the stuff that people don't want to focus on is what you should focus on from day one. Because if you're just building and ignoring all the things I said, great, but it will come and bite you at the worst possible time. I've seen so many customers, coming and say, we were fine in the sandbox, but now in production, we're spending this, or we realize, we have this security thing that, we have to implement in prod, and it's breaking the architecture. Like, you have to don't design for the sandbox, don't design for the POC. Everything works in the sandbox, okay? Design for prod for day one, and that means talk to all the not really fun people who will have to sign off on your deployment. And even if you're a startup, maybe you don't have a compliance team, and maybe you don't have a security officer, but come on, you know what to do. Nobody wants to eat their vegetables, but don't make anybody, don't make anybody force you to eat them, because it will be at the worst possible time. It will be, 1 week before you A round or something, and you have a security problem and it makes the news, or, So that's always my advice. There's way more to building on the cloud than just, clicking in the console and running like there's no tomorrow. You have all the tools you need on AWS to implement, cost management and compliance and, reasonable security from day one, and when in doubt, ask your SAs. I think that's probably advice number 2. And I'm sorry for saying this, but, solution architects are free. They come for free. They're here to help. They're not here to sell you more. They're probably here to actually help you spend less and do things right. and they've seen enough startups to understand what is reasonable on your first few months of existence, and they'll start telling you after a little while that maybe you need to look at well-architected reviews, etc., etc. And yes, and again, they know better. They've seen hundreds of customers. You've seen hundreds of customers, maybe more. So you've seen those mistakes. You know when good enough is good enough and when it's not anymore.
Yes.
There are some mistakes that will not kill a seed stage company. There are mistakes that will kill a Series A or a Series B company. And sometimes you don't know because you've been so busy building. But so trust the teams and automate. Don't click in the console, please. So I don't care if you use CloudFormation. I don't care if you use Terraform. I don't care if you use anything else, but please automate. Immutable infrastructure and all that good stuff. Again, if you're not doing that, you're making your life more difficult today, tomorrow, and forever. And right size. So AWS consultants listening to me will hate me for saying this because they have a really good business coming in and just, solving the top 10 spending problems that a lot of customers do. But again, there are lots of silly things that you should avoid and spend too much on. So I think that's really what I want to say. Eat your vegetables from day one, automate, cost optimize,
And talk to essays.
And talk to it. Please talk to essays. Essays are the best. I've met a lot of people at AWS, and I'll go on record, and okay, feel free to disagree. I don't think I ever met a solution architect that I felt was bad. I had a lot of fun with different AWS teams that shall remain unknown. Essays are the best. So if you're not using them, keep them busy, and they will help you more than you can think.
With that, I think we're good. Thank you very much. It was really a pleasure talking
Thank
to
you
you
so
today.
much. It's a pleasure to again be there and get a chance to speak even virtually with your audience. I hope this was useful.
It was very useful to me, at least. Thank you.
you.
So that brings us to the end of today's fascinating episode of AWS for AI. If you're interested in learning more from Julien and Arcee.ai, you can check out Julien's YouTube channel and Arcee.ai website. You can find links in our show notes along with resources for exploring AWS services that we mentioned today. Don't forget to subscribe to AWS for AI on your favorite podcast platform and leave us your feedback and thoughts about today's discussion. Until next time, this is Hamza Mimi thanking you for listening. Keep exploring, keep innovating, and we'll catch you on our next episode.